Hello, I'm Filippo Carnovalini and I'm here to present work we did in collaboration with the University of Padua, Free University of Brussels and Queen Mary University of London. In this work we will both present a new publication of a corpus for music research and the new method for the analysis of musical structures. First of all, the corpus. The corpus is made of 24 baroque mandes written for two mandolins, student and teacher, since these come from a method for teaching mandolin. These were written by a mandolin virtuoso from the 18th centuries, Monsieur Léon de Naples, and you will find the link to the corpus in the paper, which is released under Creative Commons license in Music XML format. Now, you might ask, why would you be interested in a corpus made of only 24 pieces in Baroque style? Well, there are many corpora of Music XML files that are available, but this one was chosen in particular for the study of musical structures. Since these are Baroque pieces that are relatively simple, being meant for the teaching of music, they show very clear patterns of repetitions and reuse of material. And since we are interested in a top-down study of musical structure, we do not really care if we do not have a large amount of music, since we use this corpus for the testing of our proposed algorithms and to test our hypothesis on how musical structure work. We call this corpus Leone because, of course, it is the name of the composer, but also because we built an anagram of this name which represents what we are trying to do. Describe a structure that can describe layered entities onto note executions. So the idea of a hierarchical description of musical structure. To describe what we did on the algorithm side, we must make a premise, that is that our final goal with this work is music generation. One common problem is music generation is that generated music often does not show long-term structural patterns. So we want to build a representation of structure in music that can capture this kind of regularities that are found, for example, in this corpus. And we want to test those on this corpus to see if indeed it can capture what this corpus has from a structural viewpoint. The main inspiration for this comes from the Schenkerian analysis, which uses reduction trees to find hidden musical structures. So, similarly to Schenkerian analysis, we use trees to describe music. The first one is directly inspired from Schenkerian analysis, and we called it the Schenkerian tree, the SK tree, which takes one or two bars of melody and simplifies those until one note is kept to describe the general contour of the music. And then we can operate comparison between these trees to build another kind of tree, the difference tree, which underline reuse of these kind of harmonic and melodic structures. Now, I'll make an example to be more clear. You can see two bars of music over the letter A, which come from the corpus, and you can see that there are 4 layers of simplification of this music. This is what our algorithm for the building of the Schenkerian tree did. It eliminates note at every level until only one note is kept, to find only the more important notes in the melody to give an idea of the contour and the general structure. Over the letter B and C, you can see the simplified and compact representation of these two trees. Now, what's more interesting about this is when we build the difference trees, which takes these compact representations and compares them to find if the Schenkerian reduction was the same, so if the same note was removed, if the chromatic interval is kept the same or is changed, if the direction of the interval is the same, if the interval is wider or more narrow. You could add potentially many features to this kind of comparisons. We used just these ones for this example. Of course, I cannot go into much details about how this algorithm works, but you can find more on the paper. What is more interesting right now is to see if these difference trees can indeed tell us something about what is happening in this corpus. You can see here a piece that comes from the corpus, which was divided into segments that last for 2 measures. And under the music, you can see some different trees that were built with our algorithms starting from this music. I'll just underline some things, others are underlined in the paper. You can see, for example, that segment 1 and segment 3 are a direct repetitions of themselves. And you can see that this is captured quite well in the tree, because every single feature is kept the same. The S here stands for same, nothing has changed. But what's more interesting is to see that our algorithm also caught the fact that there is a repetition, for example, between segment 6 and 8, but this time it has variations. So the comparison between segment 6 and 8 shows that the same structure is kept for the beginning of the comparison, but there is a variation on the ending, which is quite common for the end of a phrase, like in this case. This also happens between segment 2 and segment 4. We have the same structure here and the variation here. Now, this is of course just the beginning of a work, but it's starting to show some interesting results. Of course, we need to test it with more diverse music. And also we want to build a model that describes not just the structural commonalities within one piece, but also within an entire corpus, which would be very useful for generation. And finally, we will take this kind of trees representation and use it for a generative algorithm, which would build melodies that respect an input structure given by the user. Thank you very much for your attention, and you're welcome to give us comments and questions.